Okay, in class example 3, Eric was asked how many odd four-digit numbers there are, and that didn't go too badly. Now there's a more evil version. How many even four-digit numbers are there? This is harder, and here's why. How many digits can we put in this last space? If we want the number to be even, that means we can use 2 or 4 or 6 or 8 or 0. Any number that ends in one of those will make this even. So we have 5 choices for that spot. Then we go out front. How many choices do we have here? Here we can start with 1, 2, 3, 4, 5, 6, 7, 8, or 9. We cannot start with 0 because then it's not really a four-digit number. So we have 9 choices there. And then for these middle digits where we can put anything, it's not so bad. So 90 times 50 is 4,500. That's how many even four-digit numbers there are. Now it gets tricky. How many even four-digit numbers are there with no repeated digits? Here's how you start. You could put 2 or 4 or 6 or 8 or 0 in this spot. So there are 5 choices there. Now the trouble happens. When you go to this spot, how many choices do you have available? There's 2 things you have to worry about at once. First, this can't be 0. So the digits we are allowed to use are these. We can't start with 0 because that would make this not a four-digit number. Also, we can't repeat the digit that was over here. But wait, what if it was 0? If there was a 0 here, then we wouldn't need to worry about it because we couldn't use 0 anyway. If it's 2, 4, 6, or 8, then we couldn't duplicate that number and we'd only have 8 choices here. You can't really work both of those restrictions at the same time. And so, when you get a situation like this where there's 2 restrictions that are kind of, one depends on the other, you end up splitting them up. It's not too bad, it just takes a little extra writing. Instead of this being 2, 4, 6, 8, or 0, I'm going to do 2 separate cases. The first one is going to be the number ends with 2, 4, 6, or 8. And then separately, I'm going to do the number ends with 0. Let's see what happens now. This was impossible. Not impossible, but too hard for me anyway. Let's see what we can do with this. If the number ends with 2, 4, 6, or 8, and that's all we're allowed to use here, then there are 4 choices for that spot. Now let's try this first one and see what happens. Here, we cannot use 0. That takes us down to 9 choices. We also can't use whatever number we used in this last spot, so that takes us down to 8 choices. There's no overlap anymore. 0 and the numbers we're talking about over here are totally separate, and so there's no chance of any duplication. So we can't use 0 and we can't duplicate this number either. Now when we get to this spot, we have all 10 digits. 0 is okay. We can't duplicate either of these guys, so we have 8 choices. And when we get to this spot, we can't duplicate either of the 3 guys we've used already, so we only have 7 choices. 8 times 8 is 64. 7 times 4 is 28. 64 times 28, I have no idea. 64 times 28, 1792. So there's 1,792 numbers which are 4 digits and end in 2, 4, 6, or 8. Now, let's do the ones that end with 0. We have to put a 0 in here, so there's only 1 choice for that spot. Now, on the leading digit, we can use anything from 1 to 9. We just can't use 0, so that's 9 choices. I'm not worried about duplicating this space because we know there's a 0 here and we can't use that number anyway. So here we didn't care that here we knew there couldn't be a 0 there. Here we know there definitely is a 0 in the final spot. Either way, it makes things easier to figure out. For this space, I've got all 10 digits to work with, but I can't use 0 and I can't use whatever is here. So that leaves me with 8 choices. And for this middle spot, I can use any of the digits, but I can't use the 3 that have already been placed, so that leaves me with 7 choices. 9 times 8 is 72, times 7 is 508. No, sorry. 72 times 7 is 490 plus 14, 504. So, grand total, 1,792 choices there, 504 choices there. What do I do with those two numbers? Do I multiply them? I don't, because they're alternatives. The number either ends in 2, 4, 6, or 8, or it ends with 0, but not both at once. You don't have to take one of these things and one of these things. They're mutually exclusive. So you add these together. 1792 plus 504 should be 2,296. And that should be the total number of even 4-digit numbers with no repeated digits.